Imagine standing on a battlefield in the 14th century. The air is thick with dust, the ground trembling beneath charging horses, and somewhere in the distance, a volley of arrows darkens the sky. You cannot run, you cannot hide. All you have is the armor on your body, a shell of steel crafted by hand, designed not just to protect, but to outsmart physics itself. But how did medieval armor actually work? And more importantly, why did it sometimes fail? To understand medieval armor, we must step into a world where warfare was constant, brutal, and deeply personal. From the fall of the Roman Empire to the late Middle Ages, Europe was locked in cycles of conflict. Weapons evolved rapidly, swords became sharper, bows more powerful, and tactics more ruthless. Early warriors relied on simple protection: leather, padded cloth, and eventually chainmail. Known as a mail shirt or hauberk, chainmail was made from thousands of interlinked iron rings. It was flexible, durable, and revolutionary for its time. But it had a weakness. While it could stop slashing blows, it struggled against blunt force and piercing attacks. A heavy strike could still break bones beneath the armor. A well-placed arrow or spear could slip through. As weapons improved, armor had to evolve. And so began one of history's greatest technological arms races. The transition from chainmail to plate armor was not sudden. It was a gradual experimental process spanning centuries. Blacksmiths began reinforcing vulnerable areas with solid metal plates. Knees, elbows, and chests were the first to be protected. Over time, these plates grew larger, more refined, and eventually merged into full suits of armor. By the 15th century, the medieval knight had transformed into something extraordinary, a fully encased figure in articulated steel. But this wasn't just brute force engineering, this was science. At its core, armor design was about managing energy. When a sword strikes a flat surface, the force is concentrated in one point. But medieval armor rarely used flat surfaces. Instead, it featured curves and angles, carefully shaped to deflect blows. A curved breastplate could redirect the energy of a strike away from the body, reducing its impact. This is the same principle used in modern ballistic armor and even spacecraft shielding. Then there was thickness. Contrary to popular belief, armor wasn't uniformly heavy. It was strategically distributed. Areas more likely to be struck, like the chest and helmet, were thicker, while less critical areas remained lighter for mobility. This balance allowed knights to move, fight, and even mount horses without being immobilized. But perhaps the most fascinating aspect was metallurgy. Medieval blacksmiths lacked modern labs but mastered steel through trial and error. By adding carbon, a process now called carburization, they created armor that balanced hardness and flexibility. Too hard, it shattered. Too soft, it bent. The English longbow, especially in the 100 Years' War, forced innovation. Armor became stronger and more curved to deflect arrows, yet close-range bolts could still penetrate. Knights adapted tactics, but the arrival of gunpowder changed everything. Firearms demanded heavier armor, reducing mobility and raising costs, until the armored knight slowly disappeared. Medieval armor left a lasting imprint on both technology and culture. It represented one of the earliest examples of applied material science, long before the term existed. The principles developed by medieval armorers, energy dispersion, layered protection, and material optimization, are still used today. Modern body armor, riot gear, and even vehicle design borrow from these ideas. But beyond technology, armor shaped society. It reinforced class divisions as only the wealthy could afford full-plate armor. It elevated the knight as both a warrior and a symbol of power, and it created a visual identity that still defines the Middle Ages in our imagination. The shining knight in armor became more than a soldier, he became a legend. In the end, medieval armor was never just about steel. It was about survival in a world where every innovation could mean the difference between life and death. It was about human ingenuity, solving problems without modern science, relying only on observation, experience, and relentless experimentation. And perhaps most importantly, it reminds us that even in the past, people were engineers. They understood the world not through equations, but through necessity. Every dented helmet, every polished breastplate carries a story of impact, of resistance, and of the timeless battle between destruction and protection.